Hello, good evening, everyone. Welcome to the class today. I don't know, Mr. Chinedu, can we start, Mr. Victor, can we start right away or do we wait a little?
Yes. You can start.
All right, all right. Good evening, everyone. Good evening. Right, Ekemeze, I guess you are here. Yes. Good evening, Mr. Victor and everyone. It's going to be a wonderful session here. I hope we are all ready to make the most out of tonight. I don't know if there are reactions. I would like us to be using reactions so that it shows participation instead of just keeping mute and trying to listen. I think we can use those emojis and communicate attention. So please, if you can hear me right, Victor, can you put a like? See the heart icon there. You can put a thumbs up, or put a clap, or put a love. Anyone that you feel like doing something like that. So please, we really need this to keep up the energy in the class. Yeah, I can see Bright. I can see you, Bright. Victor, yeah, thank you very much for that. Okay, so let's get started. It's a wonderful thing that today we are running this, we are starting this wonderful adventure. Our adventure into software engineering, our adventure as software developers is going to be wonderful. It's really going to be wonderful. I'm glad to have you all here. It's nice. So do you have your materials? Like I said, do you have your laptop? We are going to do some little, not coding though. We are not going to do any coding. I'll be showing one or two things and illustrating one or two things. But from tomorrow, get ready to do some code. So are you ready with your laptop? You can give me a thumbs up so that we can push through with it. Oh, great. Right. Okay. Victor, I see you. Okay. That's nice. That's nice. So let's move. Let's push it. We are going to be discussing today about computer programming. Computer programming, and then before we close the class, we can look a little bit into HTML and CSS. So what is computer programming? We all know what a computer is. It's a device that takes information and data and can interpret it and display it and return it according to what we ask it to do. So basically, a computer is a machine. Just like we say way back then in secondary school, a machine is an instrument that makes work easy and fast. A computer is actually a machine of its own sort that helps to deliver tasks, that helps to work out things, make calculation, display things, look through things, read through things, watch things. Way back then, our laptops used to have video CD player, and then you can put in your CD, your discs, and play your videos and all that. Or you have the floppy disk, that diskette that looks big. You know, there are a lot of things that's input devices. These are input devices. And so, what does a computer do? It takes from an input device the data and then it returns an expected or a required result. Take, for example, when you put in a floppy diskette, floppy diskette from way back 20 years ago or 25 years ago, when you put in something like that, you now have access to the files, to the texts in the floppy disk. And from there, you can, copy, paste, and even resend. So these are advantages of a computer, things that you can use the computer to do. So a computer is a device, a machine that makes work easy and fast. And what kind of work? Mostly software work. What are software works? Software works are like works or outputs that can be seen and not felt. Software works are digital or visible outputs or information that you cannot hold by your hand, but you can look at them through a screen or through a user interface that causes you to view them and see them the way they are. So what is computer programming in essence? Since we have addressed what is a computer, please can I get a thumbs up? If there is any question, please don't delay to raise up your hand and ask a question. If you have any question, if anything seems unclear, you can raise your hand. There is a raise hand icon here. I think so. There's a raise hand. Yes, exactly. So as you can see, my hand is raised in that icon. If you tap on it, you lower your hand. In that same love icon, in that same love emoji icon, you find this icon. So as we go through the class and you feel like something is not straight with you, something is not so clear to you, or my voice is wobbling, or my voice is too weak, or too quiet, or too low, that you cannot hear me, or the network seems to be breaking, please raise up your hand and we can address whatsoever issue, because we have to be following up with this class. It's an advantage that we are few here. So we'll make the most out of it and make sure everybody is carried along. If you buy that idea, can I get a thumbs up? Can I get a thumbs up? Hello? Can I have a thumbs up? Great, 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 great. Okay, so we proceed. What is computer programming? Since computer is a machine, it means it cannot work on its own. Since computer is a machine, it means it was created by someone. It was created by something that has to be maintained. So now, what is computer programming? Computer programming is the exercise wherein a computer is leveled to the understanding, to its understanding, and commanded to, execute a particular task, to deliver a particular task, to render an output, to process information and data. So what is information and data? Data and information are the two primary things that make up a computer or a digital device. They are the two important things. Take, for example, in a human being, we have what we call vital organs. Vital organs, the heart, the kidney, the blood. They say the life of an animal is in the blood. So imagine the life of an animal being in the blood. That means that the life of a computer is in its data and information. Once you cannot send or receive or even do both, a normal computer sends, receives data and information. Or at worst, there are situations where you can only send data, you can only receive data. So in a situation where a computer cannot produce data, cannot receive data, that computer is useless. It cannot do anything. It's just as good as a dead human being who has no brain and cannot move around. So the basic functionality, the heartbeat of a computer, the importance and relevance of a computer, the use of a computer is for data processing, data displaying, data collection. Data collection, once again, data processing, and data displaying. I come again. The basic function of a computer is for data collection, data processing, and data display or rendering. And it does that through a visual interface. The displaying, it does that through a visual interface. The data collection is done through input devices. What are input devices? Input devices are devices that we can use to feed data into a computer. We can use to get a computer to have access to a particular type of data. So these are the key features of a computer: data in processing, data intake, and then data delivery, rendering, or display. So we are going to be looking at some other things. Like we said, computer programming. Computer programming is the process. Sorry, I didn't fully deliver that. Computer programming is the process by which we construct some lines of actions and deliver it to a computer to follow through. Computer programming is the process of commanding a computer to follow a particular pattern or thoughts or display a particular set of data. So we are going to be using some kind of detail. What would I say? We are going to be using some kind of typical definitions so that we can use that going forward in case they ask you in an interview or whatsoever, what is computer programming? Let's have it in a particular kind of way that you can relate it and then have a good score that this person, he really knows what he's saying. Because most times in interviews, they can get as serious as asking you basic questions. And these basic questions is very important, the way you answer them. Even if you don't answer them correctly, most interviewers are looking for key points with which to, mark you right or wrong. So computer programming is the process of creating instructions for computers to follow in order to perform specific tasks. I come again, if you have your pen and your Bible. Computer programming is the process of creating instructions for computers to follow in order to perform specific tasks. Computer programming is the process of creating instructions for computers to follow in order to perform specific tasks. So most of us know about software engineering, know about software development. They are more like the same, but they are not really the same. When we begin to break down the context of software development and engineering, but that will not jumble on your minds up with that now. It's not necessary. So we'll just move into the most important parts: software development, computer programming. These two things mean the same thing. But in the aspect of computer programming can actually be a process to command or create for a hardware. Yes, hardwares are also programmed. Take, for example, sorry about that. Sorry about the thought. Please, can you send a message? I'm going to view messages. Yes, please can you send a message so I can view messages? Sorry about that. The call is interfering in my session. So I'll view your message. Just a minute, briefly. So okay. So I can make a whiteboard so we can get interactive. Can make a whiteboard so that we can see what we are talking about. Just give me the little time so I can get definition here on the whiteboard. So when we are talking about computer, it is broken down into two elements. We have the hardware, we have the software. Yeah, I'm on it. I'm trying to get the data and put it on the whiteboard so that you can see on the whiteboard what we are saying. Okay, so when we talk about computer, we have two key elements of a computer system. We have the software and we have the hardware. Can you see the whiteboard? Please give me a thumbs up if you can see a whiteboard that just popped up. Okay, Victor, great. Right, are you there? Oh, awesome. Okay, let's go. Let's get this moving. All right. So computer programming. So computer programming is the process of creating instructions for computers to follow in order to perform a specific task. So we have different types of computer details, computer features. They are basically divided into two. We have the hardware, we have the software. So we all know what this should be like. This is a laptop. This is a hardware. Way back then, we have a lot of big TVs. We call cathode ray tube. Back then, when we were studying science, we knew about computers that have CRT, cathode ray tube, and you see them being so big, it's a long pipe and so much weight. They are still visual display units. These screens are actually called visual display units, from where the computer relates what it has, the data, the information, the voicing it wants to give to the user. This is done through the user interface. It cannot speak to you in any other way best but than the user interface. We can also enable it to do some voicing, but the screen remains the primary interface for which a user or a human being communicates with the computer. So we have hardware, we have software. So computers are divided. Computers are basically of two parts: the hardware and the software. So like we are already on the hardware. Say the hardware are parts of a computer that we can see and touch. Parts of a computer that we can see or touch. The hardware can be seen. The hardware can be seen and touched. Yes, just like you can touch your laptop, just like you can touch your desktop, just like you can touch your keypad as I'm touching it, I'm punching on it. It is a hardware. And even the screen is also a hardware. So hardwares are parts of a computer that can be seen or touched. We have done justice to that. So softwares are parts of a computer. They are parts of a computer that can not be seen, cannot be touched, but can be seen and can deliver specific results in a user interface or graphic display units. So these two things are the same. In the old time, we call it graphic display units. Just like when we have the big computer desktops, we call them their graphic display units. Now, in websites, in laptops, when we want to refer to that term, just say a user interface, because the screen is the point, the portal where a computer gets to relate its idea, gets to relate its results to the computer, to the user. Take for example, now that I'm using this laptop, it is connected and there is a light showing on the charger, showing that it is charging. But how do I know whether this charger is actually charging this computer? It is when I now tap on the keyboard and I go to the battery section and I see battery fully charged, 100%, power source, power adapter. So these details are what gives me assurance, what gives me an understanding that this laptop can go some extra time, a little time, even if it is not connected to electricity, because the battery has been charged. So when the battery is low, you will also see it here. So this is what software does. It was a software that was programmed to display that detail, to check the system, to check the health of the battery and know whether or not the battery is alive, is spoiled, is about to die, is low, or is filled. Sorry, let me clear my throat. Okay, so having addressed hardware and software, we're going to go deeper as we move into this software programming, computer programming. So what is computer programming? Like we say, it is a process of creating instructions for computers to follow. Please, this is the basic reason for which we came here. Please, if you forget any other thing, don't forget this thing. Computer programming is the process of creating instructions for computers to follow in order to perform specific tasks. Ladies and gentlemen, this is what we have come here to do today. To learn how to write, how to create a set of instructions that the computer has to follow in order to perform a specific task. In order to tell the user battery is low, connect to a means of electricity. In order to tell the computer that when the disk is loading and nothing is found in the disk, that it should reject the disk. These are all programming. That one is hardware programming. We are programming a hardware so that when it tries to read a particular disk file and fails, that it will show an error to show that the file was not able to be read, or that it will just spit out. If you remember in those days of cassette players, of CD players, if you put a bad cassette, after turning and it does not give any song or sound or video, the next thing you see is you make a sound and it will bring out that particular disc or cassette back to you. These are all programs written. These are all sets of instructions that have been passed into the machine, telling it if this and this happens, if you are not able to do this, do that. So it's so interesting that a lot of if and else exists in computers, because we don't just write a code, we don't just program a computer to do things one specific way. And then if it fails, it does not have any way about it. It is just got stuck. It doesn't happen that way. Even as human beings, we can send somebody to somewhere, meet this person. If he's not around, start coming back. If he's going to waste time, start coming back. But if they tell you that he's close by, you can wait. So there is nothing difficult about computer programming. It is just like life in itself. It is just like art in itself. It is just like building in itself. The same thing that a mason or an architect does, or a construction engineer does, or an electrical engineer does, by creating things out of the scratch from available materials. That is the same thing we have come to learn here. How to make computers do things in a particular way. How to create software. We build software, we build features in a computer that will deliver a particular set of tasks. Okay, so thank you, thank you. Please, you can always give a thumbs up. I'll be asking for it from time to time. Are you with me? Victor, can I actually hear your voice? Bright and Victor, please, can I hear your voice? You can just ask me to write on. Yes, let me hear your voice and know that you are here with me.
Yeah, all good, all good.
Yeah, maybe. Oh, great, great. Thank you, Victor. Thank you, Victor. How about you, Bright? How is your, how are you so far at your end? Oh, wonderful, wonderful. Thank you very much. Oh, wonderful. It's great to hear your voice. It's great to hear your voice. Yeah. So we keep pushing, we keep pushing. So there is nothing difficult. I want us to, actually, early this year, I started thinking about that. A lot of us, even software programmers, we admit this job is not easy. What is easy in this life? Even relaxing, even chilling, is not easy. Because for you to chill, you must have that confidence that if you are not doing anything for 1 day, 2 days, that you will have food on your table, or that you are traveling all around the world. You will not travel around the world with empty pockets. So nothing in this life comes easy. We have to prove ourselves worthy of anything we venture into. So don't let anybody discourage you that coding is hard. This one, it is meant for genius. Who is a genius? A genius is somebody that just by the course of exercise continuously teaches his brain how to do something better and better. And in the course of time, that person gets so good at that thing, even without a thought, can execute it. Everybody is a genius. It just depends on how you position and train your mind and discipline your mind in order to do things. So I want us to, even from this first day, debug our mind from all those stories we've been hearing, that it is hard, that's so hard, that is hard. Nothing is easy in this life. Nothing is easy. It is just setting your mind. It is hard to play football, but Messi and C. Ronaldo are the greatest players that we have. So nothing is easy. Nothing is easy. It's just about us putting our minds to it and getting it done. So we are going to try as much as possible to demystify software engineering so that you go into it with so much optimism, and it will help you. Honestly, my story so far has been a story of optimism, has been a story of encouragement. At each and every point in my learning, I always found reasons to encourage myself. I always found reasons to push harder. I will tell you again, like I said in the previous class, when I went for a boot camp, I had already started, looking into one or two things in software programming. But there is this boot camp in Nigeria, although they are not really offering the services I enjoyed that in 2023. Then they will screen you, they will assess you, and if you are fit, if you pass their assessment, you will come and stay for months, at least 4 months in their facility. They will provide you with food, data, and all you have to do is code. They will be piling tasks on your head. Like they will pile tasks on you when you start working as a junior developer. They will put us through all those tests. And even in that, I wasn't doing so well. But I kept on encouraging myself. It was so bad that, my stack associate, we call them stack associates, the person that used to, monitor you and check up on you, help you debug code and all that, he got impatient with me to even start discussing me in the meeting that I am not doing well. You can imagine. But eventually, before the program ended, the same he commended me in a meeting and also commended me directly. How did that happen? Was it rocket science? No. There was nothing else I did. There was no magic I did rather than consistently pushing at it. Consistently pushing at it. Keeping on doing the work. It was seeming, even till today, there are some things that they taught then that I am still yet to understand. Please don't ever get frustrated. There was a video I was watching. 10 years programmer, and he was looking for documentation or information on Google on how to do something that we will address in week 1. Yes, it can be that funny. Just like you will stand and hold your key in your hand sometimes and you'll be looking for your key. It's nothing supernatural, it's nothing out of order. It is real life. We are human beings, we are prone to have lapses from time to time. So don't think that forgetting what we taught today will make you less of yourself or will make you not fit to continue with this program. It's not true. It's not true. You will try your bit. I will follow up to make sure that we are trying to assimilate what we are learning. But at some point, if there is a particular set of information, a particular context, a particular topic, like software or hardware, that may seem difficult for you, don't mind, don't reason it. Just keep pushing. Make sure you are picking up something. And it will amaze you that in this next 8 months, that you'll be at a place that somebody will ask you, so what are you into? And you say, I'm a software developer. And you can defend that. So I want to congratulate us all once again for embarking on this novel step. And I know that it would turn out wonderful. It will turn out to be something that we'll never regret. I am not regretting it at all. The only regret I have, like I said the day before yesterday, is not starting when I started. I opened Free Code Camp in 2017. But all these stories of it's hard and this one and laxity made me back down, step down. But when I embraced it by God's grace in 2022, it was on another level. And till today, I'm happy I did that. So face your fears, face your challenges, face your bugs, and while you are facing it, know that you are not alone. At least, even through and after these 8 months, it is so nice to meet you all, and it is so interesting that we are few. So even after the 8 months, it is not going to be difficult to get access to me, to discuss with me, so that even when you find a job in the field and you have a blocker, you have someone that you can say, please, what do you say about this? How do you see this? I can hop on the screen and help you deliver your task and collect your salary at the end of the month. What else are we talking about? So that is the beauty of community. That is the beauty of having someone walk you through. And another advantage, having someone that can fellowship with your challenges or whatsoever you might see as a problem. I don't think there is any problem that anybody here will have today that I have not had. So I will know the best way to approach it. And I know and I believe that it is going to turn out awesome. Let's proceed with the topic. Let's proceed with what we are discussing so that we get the most out of tonight. We already have 30 minutes gone. So once again, software, parts of a computer that cannot be touched but can deliver specific results in a user interface through a user interface or graphic display units. Forgive my typos. I think you can guess out what I was trying to imply. Yeah. So hardware, once again, can be seen and touched, and they also help in receiving and in processing and in giving out data and information. They are output and input devices, hardware. Take, for example, input device, a photocopying machine. Output device, still a photocopying machine. Why? It takes in an empty piece of paper and it fills it up with texts and it brings it out to you, and you have a palm sheet, you have a pamphlet, you have a documentation, you have a paper you can read from. So there are other input devices. We have the keyboard. Keyboard is an input devices. So now, once again, we are talking about what? We are talking about input devices. Input devices. What are input devices? They are means by which we communicate to the computer. means by which they communicate to the computer or feed it with data and information. So input devices are means by which we communicate to the computer or feed it with data and information. Input devices, your keyboard, I am typing inputs. That is, you see these texts that we are sharing online. Somebody here is in Canada, somebody here is in Nigeria, and all of us are at different locations. But this input device has given us the advantage of sharing ideas and knowledge and even text. So all of us in our different locations on this wide, unimaginably wide and large universe, we can all see what I'm typing. Input devices, which means they are devices by which we communicate to the computer or feed it with data and information. What are output devices? We can guess that out. Can I see a thumbs up if we can figure out output devices? We will not ask questions at this point. So just give me a thumbs up if you can figure out what output devices is. Oh, thank you, right? Victor, I know you can figure that out, right? Output devices. Let me see your thumbs up. Yeah, great, 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 great. Okay, so output devices are means by which we receive data and information from the computer or output device in particular. Let's just write from the computer because in the context of what we are learning about computers. So output devices are means by which we receive data and information from the computer. What are output devices? Number one, printer. Number two, visual display unit, that is screen. Screen is the ultimate output device. It is the advantage of screen that we are having this call. It is the advantage of screen that we are typing this text that you are seeing. It is the advantage of screen that we can see the names of the different people that are logged on here and can see the network status and can see how many people are connected and can see the scheme and what we have to deliver the deliverables for today. So output devices are very, very crucial in interacting with a computer because whatsoever you feed it, it is via the output device that you get to know whether it's processed that information or that object or whatsoever you gave to it and what it now has to give to you. So output devices, the screen, the printers, the photocopying machine, these are output devices. What else? Let's move forward. We're going to be discussing about writing code now. So what is code? What is code? Code is just a set of instruction, computer code. A set of instruction. Let's go. We have some good time. Yes, we just have 35 minutes spent, so we have some good time to break things down very, very well. Yes. So what is code? What is your code? Pass me the code. Code is simply a line of information that is not accessible and is not understandable by everyone, that is being delivered from one point to the other. That is code. A line of information, a line of text, most especially text information, a line of inputs that is passed from one end to another through a secure means, either by the syntax or by the arrangement of its details, not to particularly show what it meant. So when you are typing 1, 2, 3, 4, 5 in your phone, and it is showing your phone is, if you want to unlock it, it just shows enter password. And then you are entering it, and there is no way it covers it. Like some laptops and phones do, they will be putting star, 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 star when you are typing it. Unless you want to see, you now tap on a button. So if it is just that way that it is open and you are typing the password. It is not code. It is not any password. It's not any code. It's not any password. Because if I look into your computer and see Bright or phone and see Bright, he's typing as his password Bright and he types it. When I get his phone, I'll just type Bright and I'll get access into his phone or his computer. So what is code precisely? Like we said, code is a means of passing information securely from one point to another. So why do we call computer programming coding? Why we call computer programming coding is because if you know everything about something, there is nothing special about it anymore. Why do I say that? Once again, I said, if you know everything about something, there is nothing hidden or special about it anymore. If you know everything about how this computer, the information this computer was fed with, and how it was built, there is nothing special about it. So that is actually an advantage that we have as programmers, because in the course of using a lot of code and writing a lot of code, we can be able to figure out, even if it is not the particular syntax, even if it is not the particular messages that we are fed into a computer, we have an idea of what was written into the computer to make it behave this way. So code is the process of writing secure information into a computer to make it behave in a particular way. Hello? Can we have a thumbs up if you are following? Thank you, Chinedu. Thank you, Victor. Thank you, Chinedu, Victor, for that. We have two Victors, so please permit me to be calling you Chinedu while I call Abdia. Oh, great. So, Victor, yeah, thumbs up. Great, 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 great. Let's get this moving. All right, so code is just typing information to a computer. They say bro to bro. Like they usually say this in social media, bro to bro. Yeah, you are communicating with the computer, bro to bro. You are telling the computer, bro, I want you to do this particular thing, this type of way. And why is it code? We are not just typing it like English. Why are we not typing it like English? Because the computer is not a human. Because the computer is a machine. So the code that we are writing is not actually code in all of its essence. Why it is code is because it is a means of communication that is secured and organized to convey information from a user to the machine, which is the computer. So we are writing code, not that it is so secretive and so secure, and how do I put it, is not obtainable to anybody, but we are calling it code in the sense that it is not normal English. You don't tell a computer, hey, Mr. MacBook, whenever you see a call from this person, show me that the call is entering. That was not how the programmers built it. It was a line of code. It was a particular set of instructions. This thing down that we say was actually what they asked the computer to do. But when a layman sees that, the layman will not know that it is what it is actually saying. So computers don't understand English. Thank God for the emergence of AI that is now helping computer break down English, and even some interfaces like we use even in the earlier computers that help convert. We call them virtual machines or compilers. They help to compile, they help to convert literal English, literal information in text, in ABCs, in languages that are spoken and written by human, from the human or the user into the computer. So this pass from the human or the user into the virtual machines. The virtual machines now take it to the compiler that transform it to machine language. Now, what is machine language? We also call it machine code. What is machine code? Binary digits. What are binary digits? For some of us that did further maths in school or engineering and stuff, binary digits are zeros and ones. Computers are basically built with zeros and ones. What a computer understands in the integral part of it is zeros and ones. The yes you are typing to a computer it is taking it and compiling it to form a set of data in zeros and ones that equates to the word yes. So everything that we are doing, as crazy as it is, as crazy as it sounds, is compiled and converted by a computer to mean zeros and ones. I'll write it down. Computers are communicated to by the advantage of a user interface. The language is zeros and ones. Yes, the language of a computer is binary digits. Yes, so that is it. Computers are communicated to by the advantage of a user interface. The language and input device, yeah, or input device. Okay, the language of a computer is binary numbers and digits. That is zeros and ones. So here we have what we can. You can see this lining up. When I say lining up, I mean you see a lot of it like as easy as. You see, and it can go on and on and on, and then you are scrolling and scrolling and scrolling, and all you get to see is this thing. That is how amazing computers are. This is a very huge set and piece of information for it as you see this. Zeros and ones, this can mean a particular set of instruction that you as a human being do not understand, but a computer has broken it down. It does not only break arithmetic numbers down. There's numbers are what are normally broken down to zeros and ones, binary digits, but it's also by the advantages of the compiler breaks down letters and words into zeros and ones. That was why a brilliant mathematician once said that life is all about numbers. Life is all about arithmetic. So everything concerning technology and computer is hovering about these two digits, zeros and ones. So the compiler takes the advantage of its capacity to receive information from a virtual machine, whether numbers, whether texts of the alphabet, whether some particular line of instructions in voice or in letters, and then takes it to the compiler from the virtual machine to now turn it to zeros and ones, which are now served to the computer. So when you serve this to the computer now processes it. And if you are asking it to do a particular thing, if it has also been instructed to do that particular thing, it does it straight away. So that is how computers are communicated to. Just like I said, computers are communicated to by the advantage of a user interface or input device. I would like us to take note of these things. I hope we have taken note of them so I can clear this whiteboard and then use a fresh sheet to convey more information. Okay, great. Right. Thank you very much for that. Victor, can I clear it out and give a thumbs up? Hello, Victor. Are you there? Oh, great, 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 great. So let's clear this out and then continue to. Okay, awesome, 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 awesome. Awesome. Yes, 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 yes. Okay. So how do we now write code? Code, just like we said, is a particular information that is transferred from a user to a computer to direct it to execute a particular task. And then this is converted by languages, by syntaxes or programming languages into the from the user via the virtual machine into the compiler. So it's a way of commanding the computer. It is a way of controlling the computer. It's a way of creating things with a computer. So programming languages, what are programming languages? Programming languages are syntaxes. Let me write this down. Okay, so I don't know if we can do like 5 or 10 minutes break so that we can take a breath of fresh air after 1 hour and then come back so that our minds are not so bogged up with 3 hours straight of feeding of data and information. I think that works. So we'll be looking at, taking a break of 5 minutes or 10 minutes. Just stay by, you are not going far. You are just, more like relaxing and trying to ponder or go through what just happened in the past 1 hour. So we are going to be looking at doing that. So we come back refreshed. You can grab some coffee. You can have some water during that time, and then come back to the class. So please don't get tired. Don't get discouraged. This is just the start, and it is awesome. So let's proceed. Programming languages are syntaxes that are used to communicate instructions to a computer to process or display data and information in a particular kind of way. So briefly, we are going to break a context down. Sorry, we're going to break a context down here. You hear data, you hear information. Are these two things not the same? If I ask you, will you say these two things are the same? Yes, they are the same, but they are not the same. Why would I say they are the same, but not the same? They are the same in the sense that they almost mean the same thing: data and information. Data and information. But when we look down into it, data is unprocessed information. Why information is processed data? So you could have data that you cannot analyze. You could have data that you don't understand. It is a piece of information. It is kept, maybe not for you, maybe for you. But what now makes it understandable for you or for whosoever comes across it and qualifies it to be a piece of information is that it has been processed to be accessible to you or to whoever comes across it. Now, by the advantage of programming, we can make something to be a set of data. And then as a computer programmer, you know what it is. It is information to you because you can process it on your own because it is raw information. Yes. So information, data, let's start with data. Data is information in its raw state. Information is data in its processed or refined state. So we can see the interconnection. We can see how related these two guys are to each other. Data is raw information. Information is data that is processed or refined. So both of them are intertwined and look the same, but they are not really the same. Data can still be information. Information can still be data. It depends on the person seeing it, and it depends on where it's being displayed. So when you are seeing, for example, the data of an API, the result of an API, it is an API that is checking that you, Mr. Chinedu Victor, you, Mr. Bright Ekemezie, you, Mr. Victor, we are all signed into Zoom application. The API confirms this and then tells the user interface, and it displays our informations as users of Zoom application on the user interface, on the graphic display it. So that when you look on your screen, you can see your name there, you can see right here name there, you can see Victor's name there, you can see my name there, and we can see the names of everybody that is part of this meeting. Why? By the advantage of the API, of the server, presenting that data. So to some people, they might see it and they might not really know what it is. To them, it is data. But us that know that it is a display of the users available on the core, like every other normal human being will actually do, is we know it to be information. So it is information. Information is data in its processed or refined state, while data is information in its raw form. Having done that, we can move forward. So programming languages are syntaxes that are used to communicate instructions to a computer to process or display data and information in a particular kind of way. So what types of programming languages do we have? Programming languages do we have? We have low-level programming languages. We have runtime environment programming languages. We have high-level programming languages. We have superscript programming languages. We have a vast variety of programming languages. But we are going to pick them according to the frequent ones and the conversant ones that are being called. So we have examples of programming languages. Examples. We have Java. I know some of us might have heard about Java. If you played some of these old Nokia phones way back then, I would like to take us way back to memory lane to help us understand the context and the course we are addressing. If you remember, there is this platform, there is this application that runs games in small phones there, all these small Nokia phones there, and it will write Java for you, and it will show you one cup like that. If you remember, to show you one cup like that, and it seems like there is tea inside of it, you know, and then you see this white smoke kind of something. You can give a thumbs up if you remember. Do you remember? Yes. Because you remember that? Yes, yes, yes. Nice, nice, nice. So you now see this name, Java. What is happening? It is just a trademark. It is just a trademark. So remember this. It is an interface that displays when we run these games on our small Nokia phones there, on our 2700, on our Symbian phones and all that. It's very interesting to remember those days when we logged a lot of games that seem to be child's play now. So this was the platform that was used to develop these games. So when you build the games, just like if you play recent games, if you play all these high GPU games on phones now, you will see some of them, they will write Unity. They will write Unity as they are loading. Unity is the framework that was used to build them. So Java is a language that is used to program a computer that is used to program a processor. Now, let us break this down in the real sense of it. Do you really know that a phone is a computer? Yes, a phone is a computer, but they are graded as mini computers because of what? They cannot collate, accept, process, or display large amounts of data like a computer does. So we now call them what? Mini computers. Mini computers. So, sorry, just give me a second. Let me grab some water. Get it short. Great. So, programming languages are simply syntaxes that are used to communicate instructions to a computer to process or display data and information in a particular kind of way. So when they tell you, so what language do you know how to write? What is this one? This one? Can you write this one? Can you write this one? Yes, you might not know how to write several programming languages, but one language is enough to make you live very, very comfortably well. And also one language is enough to make you understand. That is why a lot of mentors in social media, which are also advise us as we have decided to take this path, we have to start going online to follow a lot of people. Like me, when you come to my YouTube page, algorithm knows the most things I search. Is either how to do this, how to do that, how to do that. So a lot of them, I'm following them and they're displaying data of, programming mentors on my YouTube. So, knowing one language can actually go a long way. One language can teach you and make you understand the concept that you will use to learn other languages in a snap, in the snap of a finger. Most of these mentors, they will tell you they know 5, they know 6, they know 7. They did not just start learning 7 all at once. No, it didn't happen that way. They learned one, they mastered it, they understood it, they knew how to make accents and intonations in it. It's just like being a native of a particular place. Like I'm a Nigerian and I'm from the Igbo tribe. So Igbo tribe, we have our own language. We have our own way of speaking. I believe all of us here are actually Igbo people. Yes, interesting. All of us here are Igbo people. So our, our language, our language is the way we talk. But it's so interesting that even in the Igbo tribe, there are some particular people that when they are speaking their Igbo, you'll be lost. You will not know what they are speaking because they have their accent. They have a way they have mastered to relate to each other, and now is an accent. So that does not mean that when every other Igbo person is talking in the normal native Igbo, they will not understand. So this is what we do in programming. Programming is life. We can relate everything about programming to normal life and demystify it. There is no winch. Nobody is a winch. Nobody is doing any supernatural something when they are writing code. They just understood how to discuss with the computer. So just like you see a husband and wife, sometimes they will be talking silent. You might be between a husband and wife. You are between them, they are talking. You are not understanding what they are saying because maybe some of the words they are muttering it, but they are understanding each other very audibly and clearly because the man knows that when the woman does that it is yes. When the woman does that it is no. They understand each other. So that is how computer programming goes. You get to understand how to tell computer to do jump up with Java jump down with Java. You know how to write jump up with Java, know how to write jump down with Java. You discover that if you now come to a software and application that wants you to now use Python to say jump up and jump down, what do you have to do? It's even easier than learning a new language, human language. All you have to do is check how to on the internet, or thank God for the advantage of AI. You already know how to say to your computer in Java, jump up. You just take it and you find somewhere that will explain to you how to say jump up in Python, and that is all. You will deliver it. So a lot of people you see today who know several languages, like me, I've started learning Python. I know Solidity, the language for blockchain development on Ethereum network. So I know this language, but what was my foundation? JavaScript. So of that takes us to another example of programming languages. So we have JavaScript. JavaScript is a language that runs on the web. It's so popular today because it is the language of the web, both on the back end and the front end. There are a lot of great, mighty things, wonderful things that can be done with JavaScript. We have TypeScript, a subset of JavaScript, but more type specific, more static, more organized, more structured than JavaScript. We'll come into that when we begin to break things down. But you don't need to. This is all you have to know. We have Python. We have C Sharp. The languages of guys that C Sharp. Yeah, that's just a rhyme we used to do back then when we are learning coding. So C Sharp is another language. We have C. We have C++. So the mother of all these guys is what? C. C bettered C++, C bettered C Sharp, just like JavaScript bettered TypeScript. So these are languages, these are syntaxes that are used to communicate to the computer. We'll go for the break by 10 minutes past 9, and we'll be back by 15 minutes past 9. Or Mr. Chinedu Victor, is that okay? I think that is okay. 5 minutes break is okay.
Yeah, sure, you can shoot.
All right. Thank you. So we have JavaScript, TypeScript, Python, C Sharp, C, C++. These are all languages. What do? They just direct the computer. So another thing that might look different when you are trying to use these different languages is that they have different frameworks. Just like that game we talked about that opens in this with this screen. It was the Java framework that was used to write that game. So when you now load the game, having been built by this framework, they will now advertise themselves for you before they now show you the game. They will now try to tell you that, hey, Omo, this application was built with our assistance. So they will now display to you this interface saying Java. If you are playing a high GPU game like some of the amazing games we have on our mobile phones now, when it's loading, it will tell you made in Unity. Unity is a framework that is used to build gaming applications. So this is all just about programming languages. There are ways, there are taxes that are used to communicate instructions to a computer to process or display data and information in a particular type or kind of way. So we're going to be looking at basic concepts of computers, basic concepts of computers.
Sorry, Daniel. Sorry, Amazon, can you hear me?
Yeah.
Yeah, so what time do you want to go for the break again?
Okay, 2:10. 9:10, 21:10.
That's fine. That's fine.
Okay. Okay, that is in the next 4 minutes. I guess some of us are in different time zones. I mean, in the next 4 minutes, we'll be going on the break. Yeah, yeah. So we're going to just, do a barge into basic concepts. Then when we are back from the break, we can now, we can now go deeper into it. Basic concepts of computer programming. We have variables, we have functions, we have loops, we have conditioners, we have data structures. Let us not be discouraged. These are all interesting key features of computer programming, variables for storing and manipulating data, functions, reusable blocks of code, functions, just like they are called, function, going for a function, by performing a particular function. These are blocks of code that define or execute a particular task. Loops, repeatable tasks, we call them iterables. We call them iterables or iterables. Sorry if there's anybody here who is conversant with UK English, they can help us. Iterables, yes, iterables. So loops are processes through which we make use of iterables to provide a particular kind of result. Conditionals, just like I said, when we are commanding a child, go and buy this thing for me. If they don't have Colgate, buy close up. If they don't have close up, buy another brand. If they don't have any of the brand, come back, let us use salt and brush our teeth. So this is just the same kind of thing we do when we are writing code. Conditionals, computer, display that Bright Ekemeze is online if you find him in the Zoom call. If not, else, that is if not, do not display that Bright Ekemeze is on the Zoom call. So what happens? Immediately Bright Ekemeze hits the red button and ends and leaves. He will not be displayed here. He will no more be here. His name will no more show here. Because of what? The computer has been shown that once this particular user comes in, that it should display that he's available, he's on the call. And once he hits the red button, it should display that he's no more on the call. So that is what conditionals do. Data structures, there are particular ways of organizing information, organizing data, processing them. So that is all we have to do in the review, in the reviewing of these concepts, basic concepts of computer programming. So when we come back on the break, 5 minutes break, you can just stand up, you can stretch, you can move back and forth, just like I will do now. Give your eyes some rest. It's not always, they say, once, 1 hour, 30 minutes or thereabouts, I'm working on a computer, you can just raise your eyes and look far and all that to improve your eye health. So we can just do some of these exercises, stretch, walking about, and then thinking and meditating on what we have just discussed. And then we'll come back in the next 5 minutes for another amazing session to further understand this concept of programming languages. So cheers, everyone. Cheers, everyone. We can go. We can just, we can keep the call on, and we can just mute our microphones and then have some little rest before we continue. Okay, everyone. Hello, can we have a thumbs up if we are back? Let's get together and let's continue this interesting conversation. Yeah, thank you, Victor. I can see your thumbs up. Right, what about, oh, great, great, great. So we are back on. I don't want to ask how was our rest because I know it was very brief. So let's just bear with each other so that we can get this done with. I believe we have, yes, we actually have. Right. Yeah, for real. I know it was too brief. So let's just bear with each other, and then I know that it will get more comfortable as we go along the way. So we have a recording, we are recording the call, so can always get back to that to chew over and over what we have just discussed for better understanding and assimilation. So, like we talked about before we went on the break, basic concepts of computer programming, basic concepts of computer programming. Okay, so let's get back to the whiteboard. How do I post this? Okay, so we have all this information noted. Let me clean it. Programming languages, just a brief recap, used to communicate instructions to the computer to process or display data or information. Data is information in its raw state, while information is data in its refined or processed way. And then we said programming languages differ according to their syntaxes. Yes, syntax is just like we wrote here. Java, JavaScript, TypeScript, Python. So what are syntaxes? The particular way that we write code. Syntaxes are just a particular way that we write information to the computer to compile and convert to zeros and ones. Okay, great. All right, we have our desk clean. So, ladies and gentlemen, basic concept. So we don't have a lady here. I saw one Chiamaka. I don't know if she'll be joining. So I think that's why I said ladies. Okay, so basic concepts. We start with variables. And we're going to be using the word var. This is the typical traditional name for variables in JavaScript. Remember, yes, just either if I did not say, well, we are going to be specializing, just like I say, we take one language, we master it, we understand the accent, just like a particular village in Enugu State speaks Igbo in a particular accent, while another village speaks Igbo in a particular accent. We are going to break down Igbo so well that we now move not only from speaking native Igbo, but speaking in a particular accent. If you get to some senior type of developers, pros that are down and very, very good in code, they will see a particular logic, a syntax on a particular, they'll be like, this seems to be my code. Where did you get this code from? And you will now be wondering, how come this person knows that it is their code? Because they write their code, they instruct their computer to execute tasks in a particular trend of thought, in a particular manner of reasoning. So when we now break down JavaScript so very well, you find yourself telling the computer to do things in a particular kind of way. The same way I am explaining basic concepts is not the same way another person will explain it and break it down. So that is just the beauty of what we are discussing here today. So what are variables? Variables are used for storing and manipulating data. So when we say var x equals to, right, and we say var y equals to Victor. And we say var Z equals to Hamilton. That's my name. Or short, IK. Okay? And then we have a function. Function get Z. And what are we passing into that function? We are passing Z as an argument. And what are we saying? We are saying the computer should do what? It should console log. It should display. It should display console.log. Whenever you see this, you see it a lot as a programmer when you see console.log. Z Z is a code tutor. Yes. So look at this. This is a function. This is an instruction. Functions are instructions made to make the computer function in a particular kind of way. Let's just keep it that way. Okay? I think in the course of this code, we understand what we are talking about. So we have variable x used to store the data of the name of one of the people here as Bright. We have variable y used to store the data of one of the people here as Victor. We have variable z used to store the name of somebody here as Hamilton. And then we are calling a function. We want a function that the computer will perform. An instruction, we want to instruct the computer to say this thing. What are we asking it to say? That it should display. Console log is display on the interface. Console log, whenever you see it, console, when we say game console, it means what? A console, a means of display, a means of relating the visuals of the functionality of a game. So when you don't have your PS5 console, how can you play Need for Speed? How can you play Pro Evolution Soccer? You cannot. Until you do what? Until you buy the gaming console. It is in that gaming console that the engine for programming that game is now being run to display the game in a user interface. So what are we doing? We are asking the console of the machine or the computer that we have to now run a command that will display what? Z, the variable, a data stored. Remember, we said what? Variables are used for storing and manipulating data. So we now make this function that variable Z will now bear the advantage of the console displayed with the text that it is a code tutor. So when you run this function on your, from next week, we are going to use VS Code or Code Sandbox. I will prefer VS Code because I want us to download most of these things in our computer and start having that vibe and feeling of being programmers. And even when we are having our lectures, so you can even write down some of your notes on VS Code. It's very nice. And then if you write something like this, you write it as well. Push it to your GitHub. We are going to enter GitHub today as well, so that you create a GitHub account like we do today. We'll create a GitHub account so that you have it will be registered that on the 8th day, it is a wonderful, remarkable journey. That on the 8th day of January 2025, you embarked on your software engineering journey, and that was your first day to create a GitHub account. And it can be a great credit for you because some companies, while hiring people, while hiring developers, they will go to your GitHub to check your activity, to check how many pushes you have made. Pushes are like contributions, detailed information that you have pushed or you have taken and stored in the GitHub. So we're going to create a GitHub account and we're going to be writing some small things, some interesting things, And we're just going to be posting it there, and it will be giving you a green symptom, a green what's it called? So I don't know. Well, maybe let's okay. You are screen sharing. Okay. Okay. So can we see? Can we see? Can we see? You can see my whiteboard, right? Give me a thumbs up. Okay. Okay. Can you see another page in my laptop? Can you see a dark thing I'm using in my laptop? Or is it still the whiteboard that you can see? Okay, you can only see the whiteboard. You can only see the whiteboard, right? Reply with a thumbs up. You can only see the whiteboard, right? Oh, okay, okay, great. So maybe we'll explore the options of sharing screen. Okay, we'll explore the options of sharing screen. So I will show you the GitHub. I will show you my GitHub and show you some particular details. So, but before we get to that, we can just use our computers to do it and unmute our microphones. And if you have any glitch, I'll put you through with it. So back to the whiteboard. Actually, we have
Almonson, can you hear me?
yes, yes.
Yeah, so check at the bottom of your screen. Check that arrow that is next to the video icon. You see something like share screen.
Okay. Share screen, share screen, share screen.
Have you seen it?
No, it's now displaying several interfaces, just displaying an icon for me.
Like beside your video toggle, are you seeing an arrow that is pointing down or up?
The problem now is that the whiteboard that I'm using now has blocked. It has blocked me from seeing the basic things I should see.
Oh, I understand. You can exit the whiteboard first if you need to.
Okay, okay. Let me just explore. Okay, okay. Video options. Yeah, I can see the video icon. Video settings, choose filter, blow my mind. No.
Are you using anything like share screen now?
No, no, I can't see anything like that yet.
Are you using any monitor icon with an arrow pointing up, like on the list of things at the bottom of your dock?
No, I'm just seeing the audio, the video, the participants, the chat, the more option, and the leave.
Click on the more options.
Okay, more option. You have reset to default apps, whiteboard, notes, docs, captions, transcript, record, react, share. Oh, great, 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 great. Share, yes. Share screen. Okay, I'm on it. I'm on it. Okay, so can you see my screen now? Thumbs up, thumbs up, thumbs up. Oh, great, great, great. So you can see my screen. Okay, let's go to .com. If I show my profile, let's just go to the website itself. Oh, sorry about that. It still landed me into my GitHub. Okay. Your profile. Okay, so you see this URL, when you are making applications as a software engineer, a lot of people will be asking you for this because this URL is visible to everyone. And when they get to there, what are they checking? Contributions. 83 contributions last year. You see, my contributions are very scanty, even with the little that I know. So your goal might be even 10 or 12 or 20 in the past 1 year, but it doesn't really matter. Some people go as far as, fixing and bugging a lot of pushes to their GitHub just to show that they are active. But not everybody has that time, and not every company sees that as a primary criteria for taking in people. But one thing they would love to check is what? They would love to check when you join GitHub. So you can see mine has 2025, it has 2024. Can you see? It has 2023. So you can see when I actively started pushing was in when? April 2023. My first push to GitHub was when? On April 22nd, 2023. That was my first push into GitHub. So I would like your first push into GitHub to be 10th of January 2025. So get ready, everyone. We are going to make that milestone achievement. That's just like I'm pointing today to show that my first push to GitHub was April 22nd, 2023. You will point your first push to be what? 10th of January 2025. And that would be an awesome way to start creating visibility on the space of software engineers. So what do we do here? What are we doing here? What we are doing here is storing code. Nothing else, just storing code. You go there, you create a profile, and then you store codes. How do we store codes? We store codes as repositories. What are repositories? Folders, places that we can store code. So here you see applications that we are created as repository, and then we are using it to build applications. Let me open one. Okay, let's just open this one. Okay. So this is a folder that we use to store this code, the code for this app. And what is this application? We see in the README file, a simple React application to convert BTC to USD and vice versa, while displaying the coin prices of the top 5 cryptocurrencies. Features. Okay, yes, let's go. So now, you see we have every information about this application, including the URL. You can see, you can open this. You see assets, you see images. You open SRC, you see components. What are components? Integral features of the app. You see JSS. Can you see now? Can you see code? Can you see code? Can you see code? Can you see code? It looks like a lot of unnecessary grammar and English for you, but we'll get to start enjoying it very soon. So what are we writing here? We are writing a page that displays information about cryptocurrencies and changes their data and changes their prices. We are integrating an endpoint, a server, https.congecko for this. And we are using it to what? Display the data of what? Cryptocurrencies, and then convert them according to their current price and display them. So let us not be afraid of anything code. There is no big deal in it. So what happens? These things, this JSS file, and this styling, this is styling, next direction, background color, this one, all these stories. We are just using it to build an application that shows on the web as this. So this is all these things that we are writing there. This is what it turns out to be. Just this simple, small user interface where you can use to know how much 100 BTC is now or 10 BTC. Can you see? It's displaying to you. It is showing you the current price. Look here, it's showing you 94,100. This is just the beautiful things we do with code. These are just a speck of the amazing things we do with code. We can do a lot of magic, interesting magic. If we go into private repositories, maybe of companies we have worked in, and you see a lot of wonderful arithmetics and calculations that we have been able to do writing code. You know that code is actually art, as much as we try to scientifically define it. How do I put it? It's actually art. We are just artists creating and building and designing what computers do. That is just it. That is just it. So we're going to create a GitHub account today. Very, very important. Before we go back into our lesson, we're going to create a GitHub account. So if you're with me, just type www.github.com. We can unmute our mics now so that if there is any problem, you can always let me know, notify me in the process. I can stop sharing now. So you see something like this. Some people in the, okay, let me tap on the home page. I think it will continue my profile because I'm logged in. I don't know if any one of you can volunteer to, share their screen so that maybe I'll be guiding one person and the other will be picking up from there. Is that possible?
Amoxin, you're having them sign up on GitHub, right?
Oh, I didn't know I was muted. I was asking, what did you say? Come again.
Yeah, I said you're having them sign up on GitHub, right?
Yes, I want to help them sign up. Exactly. Yes.
All right. Also paste the GitHub home page URL on the Discord chat.
Great. Yes, that's what I'm going to do right away. www.github.com. So you can go to the GitHub, you can go to the list, what's it called? You can go to the Discord platform now and see the GitHub URL. Yes, it's posted there right now. You can just copy and then paste on your browser, and then we get moving. Yeah, let's get moving. Yes. Oh, great. So when you open the URL, you have something like a user interface that is dark or move in color, say build and ship software on a single collaborative platform. One good thing about GitHub as well is that we can use it to work together. We can use it to collaborate. When we begin our hands-on projects, that we will be writing code, we'll be sharing code, we will be contributing, putting our contributions with right, we write a front-end user phase that you use to sign in, and Mr. Victor, we write the welcome page, the dashboard, and then all of us will push it, and the app will be working simultaneously by the advantage of our pushes, our contributions to the repo, and then furthermore the deployment. So there is a lot of wonderful things that we are going to be doing in this program, and I hope we all embrace it and enjoy it. Yes, enjoy. Honestly, it gets easier at the top. It gets easier as we move. Oh, great. So please let someone share screen now. Let someone share screen so that you can, I think it really would be faster if someone can share screen and then make a guide to. Oh, Victor, that's great. Awesome. Yes. Let's go. Wonderful. Sign up. You click on the sign up button. Bright, are you following up? Please, can you give a thumbs up or you can give a response? You have put your mic now. Okay. Awesome. Yeah, great. Sign up. Click on the sign up for GitHub. Yes. Okay. You can use your email straight away. Yes, you can enter your email address, your password, and the rest. And yeah, you can choose a username. Just find a username that's best works for you. Yeah, you can look. Please, you change it. Don't use Alphabet. Your employers will be seeing that name. So you can use something that sounds, like Big King or something that might look a little colloquial, but it's still formal. Yeah, just try to make it formal. Or Victor, like Vic, Veek, and then Thor, the god of thunder, Thor. Yeah, it's a bit colloquial, but it's also informal to some extent. So just find something that is relative to English and news. Victor is not available, I guess. Yeah. Yeah.
Why is this password exposed?
You said, okay, yes,
Why is
yes, you
this
can
password
close it.
exposed?
Yes, you can just you can follow the prompt and get back to me. You can I thought you could hide it. Delete that part. Delete that part. It's suggesting a password for you, but that password will be difficult for you to remember. So delete it and then input a password that you want. But you can just stop sharing your screen for privacy sake. Yeah, click on stop sharing. Click on stop sharing. When you are done with signing up, tap on continue. Okay, great. Yes. So input your password and then, yes, input your password.
Um, Hamilton, also, what browser is he using?
I think any browser he uses works, but
I,
best
I think
as
he needs
developers,
Chrome
I
so that
really
he doesn't have
recommend.
that issue.
Yes, I really recommend Google Chrome. Yes, Google Chrome is awesome. Google Chrome is most versatile. It fits several use cases. So Google Chrome is
Yeah.
ideal. Yeah, Google Chrome is
Victor, can you confirm what browser you're using?
Yeah, I'm using Safari.
Okay, try downloading Google Chrome first
exactly.
on
It's
your
ideal.
Safari. And
Yes.
Bright, what browser are you also using?
Right.
I'm using Google Chrome.
Great.
All right, great, great,
Can you
great.
hear me?
Yeah,
Yes,
yeah.
yes.
So
I'm
you
using
can you
Google.
can you can
I
you
want
can
to
share
ask.
your screen, Bright.
Uh, I already have a GitHub account.
Oh,
Okay,
awesome.
yeah, we get. Okay, that's great. That's great. That's great.
Okay.
So let's
Yes,
let's
I already
let's
do.
let's quickly let's just wait for Victor to download Chrome and sign up on GitHub.
Okay. Yeah.
Victor, you can also share your screen during the process so that we can also help you unblock any blocker during
Yeah, I'm
this
just
download.
Exactly. Once you are done with the password and you click on continue, you can expose your screen so that we continue from there.
So another thing is that on Chrome, he will not have that issue of that password being exposed. Do you understand? Hamilton. Yeah. So Victor, you can share your screen so you could also see like what's
yeah, I'm
what's going on.
just trying to download the Chrome here.
Okay, okay. Yeah, yeah.
Yeah, it went off from my system, so I'm trying to put it back. Boom, boom.
You can actually keep pushing with the Safari, but you need to download the Chrome. Download the Chrome now. I don't think it will take so much time from your end. So why we actually choose Google Chrome against why we actually choose Google Chrome against other browsers is because of its versatility. It's mostly used by others, so we prefer it in place um, to other browsers. It's not like they won't work, but it's more ideal. It's more ideal. Because of the software development, we are going to be downloading some plugins, some dev tools, and these work very, very well and seamless to Google Chrome. So that's what makes it on the top of the chain. You're going to also download Visual Studio Code, VS Code, but that will be on your own. There's nothing much on that end. There's nothing difficult about that. But if there is any issue, you can now get to me and we can hop on a call. You can notify me on Discord and we can hop on a call and address whatever challenge. But I am confident that there won't be much of a challenge in making use of GitHub. In making use of downloading and making use of VS Code. So you can download that VS Code through the weekend and we can make use of it when due. So let's just get through with this GitHub. So by next tomorrow, we write some interesting little lines of code. We first of all clone a repo. We create a repository on GitHub, and then we'll clone it. We'll bring it down to our local machine. We'll open it using Visual Studio Code. Yes, that means we have to download that Visual Studio Code tomorrow. So I'll give you the links to download Visual Studio Code. Right, I guess you have a Visual Studio Code app in your laptop. If you don't, I'll send the link so that I'll send it right away in the Discord
I
channel.
don't have it.
You don't?
I don't have it, yeah.
Oh, right. No worries, no worries. So I'll send the link to downloading Visual Studio Code so that you can download it on your device and then be using that to write some amazing magic. Yes. Some amazing magic.
So, Victor, how is the download going?
But I'm almost done here.
All right.
So,
So what we are going to be downloading in Visual Studio is Visual Studio Code. There is Visual Studio for Microsoft. There is Visual Studio for Mac. Then there is Visual Studio Code. So the one we are going to be using is Visual Studio Code. I'll show you the icon. I'll make a screenshot of the icons.
I would also drop a link to download Visual Studio Code on the Discord community.
Yeah, I've
So
actually,
you could always access it.
yes, I've done that already. I've done that.
All right, great. Okay, Victor, have you successfully signed up on GitHub?
Yeah, this is my profile. You can see my screen, right?
Wait, scroll up, scroll up, scroll up. This looks like someone else's profile. Click on the icon at the extreme right.
This
Yeah.
one?
Yes, yes, yes.
Yeah.
That's your profile icon. So you can click on your
Victor.
profile. Check the
Yes, yeah.
yeah.
Great.
All
Great.
right. So
Great.
this is your profile. Hamilton,
Yes.
you can carry on from here.
Oh, yes, yes, yes. So congratulations, Victor. You are now on GitHub. GitHub is the standard and most conversant Git platform where we execute Git actions and store codes and work on them from that point. So it's like a cloud service. It's more like a cloud base where codes are being stored for reference purposes. And then by the advantage of Git, which is a system of orchestration used to track and to update changes to code. We can track and update changes to our code using Git actions with Git, and then push those codes and changes and updates to GitHub, a software, a center, a housing, a warehouse. So we use GitHub to track and update changes. We use GitHub to store tracked and updated changes that we are done with Git. So, okay, when you click on edit profile, click on it. We are not going to begin to edit your profile, but let me just see if there are some little guidelines that you can see what it shows you there. Name, bio, pronouns, and all that, company, websites. You have a portfolio website. Yeah, all those interesting features. You can click away from there. Yes, yes, just scroll up, scroll up. Yeah, just tap on the icon, tap on your, go up to your profile picture section. That place that they, yes, you can tap on that emoji. Yes, it sets status. You can set a status, what's happening, whether you are busy and all that, just like we set status on WhatsApp and the other social media platforms. So you can close that up. So you can see, okay, you can just close it up and maybe when you're free, you get to that. So you see, you joined GitHub in 2025. So as the years go by from 2025, you get another one, 26, 27, 28, until you are 10 years old as a programmer or even as a CEO, maybe you still try to push in code of your startup and whatsoever you are doing that time. This GitHub account will remain there, tracking and giving record and inventory of what you are doing, even as a software developer. So congratulations once again, Victor, for joining GitHub. You are now a member of the platform where developers store their code and keep track and inventory of it. Congratulations, Victor, afresh. Congratulations once again as we all take this step and make the most out of it. So you can scroll on the profile icon, move to the profile icon. No, right, far right. Far right, there's, yeah, scroll up. This is exactly perfect. Yes. So you can see this where you click on your profile and you show that place. You see your repositories. This is where you have a store. Repositories are the store, the archives of all the code that you've been writing. Your organizations. We are going to create an organization. We are going to call it, New Coda company, and we are going to, we are going to name it after the company, and then inside it, we are going to be creating the application we are going to build. So you'll be part of the organization, and so when you click on the organizations, you will see that when you get employed as a staff and the company wants you to work on their code, they will give you access to their organization. So your organization list grows as much as the organizations you join, your projects, your stars, all these things you discover it in the course of time. Sign out button, GitHub community, GitHub communications, all these interesting things. Now, let me show you another advantage of GitHub. There is what we call open source contributions. There are a lot of codes, a lot of projects that are here on GitHub that are open to anybody on GitHub to look at their code, to learn from it, to even copy it or to make amendments to it. The only thing is that they will not give right access to everyone. Imagine that you are writing a project now, you are building your portfolio website and you put in your picture. and you put it open source and there's no security, and then somebody comes and sees and says, Victor needs to look like me. I want when people click on Victor, they will see me. And then he goes to your repo where you store your profile picture, your portfolio and your profile picture. You go there, remove your picture, put his own. It won't make sense. So it is your repository. But when you are making it open source, it doesn't mean you are exposing it to be altered by anybody. You are just exposing it to be visible by anybody. This kind of people can copy your code. They can request to change your code. They don't have rights to change your code automatically. They can just request to change your code. Then if you trust them, you can give them access to change your code whenever they want to and push it, and that change will affect. So these are the amazing and interesting things we do on GitHub. When you open your VS Code and clone a repository, you can, from there, from your VS Code, push it, and it will show on your GitHub that you made this and this change in this particular application or in this particular file, that this particular file is now displaying in this kind of way. These are the amazing things we can do on GitHub. So tap on repositories. You can see it just below the GitHub icon in your left, your upper left. Hello, Victor, are you there with us? Yes. No.
Yeah, I'm ready.
Yeah, okay, yeah, go there. Yes, they will all lead to the same place. Yes, you are still on point. You see, Victor doesn't have a public repository yet. Interesting. Okay, so go to find the repository. Type banking app.
Banking app.
Banking. Yeah.
Okay.
Okay. Oh, sorry, not there. This one is the search. You can copy that and paste on the upper search. Yeah, copy that. This one will search your repository, search your accounts. You can copy that. Exactly. Thank you very much. Paste it there. Yes, you can remove the owner tag, the owner Ikewu Victor. Yes, so that it does not search for your exactly. Enter. Can you see? It begins to show you open source projects. All these things are banking applications that people are building. That is for mobile application. You can see React, Windows, Node.js, JavaScript. These are open source contributions. See, nobody is expecting you within 8 months to start sitting down like this, and just like we type letter, you'll be typing code and typing code and typing code until everything works. No, what we are expecting from you is to understand how code works, know how to source code from repositories, from resource materials, know how to refactor them to do the particular thing you want, and then even know how to write some basic elementary code, which will be demanded of you in an interview. Imagine they now tell you to create a counter app that when you click on the button, it will be increasing the number of counts that is on the user interface by 1, and you're tapping on it, and it is 1, 2, 3, 4, 5, 6, 7 as you're tapping on it. They can ask you such a question in an interview. So all you have to do is, feed the information, write that simple code. But nobody is asking you to write 1,000 lines of code all from your head. This is the way you can find code. This is the way you can find assistance. And as you grow, as you keep building projects, you work for a bank and they build a tracking system for email. And then you go to another bank because the bank is offering 50,000 naira or $10,000 extra to the wage per annum. And then you join that other bank and they ask you to create an email tracking system. Will you start building an email tracking system all from the scratch? Hell no. These are the sweet spots of this career. There is a level you will get. What it will take one person 2 weeks to do, you do it in 2 hours, in 2 days. And because you can produce that kind of effect and value within that time period of time. Nobody will tell you, is it not 2 hours that you worked? They will pay you more than the person that's sweated, that's had sleepless nights to build it. But these are all levels. So these are materials you can use. If you want to create a banking app, you open one, tap on the Derrick banking application. Yes. Yeah, exactly. So nothing big. Tap on src/main. This is where the major codes are being kept. Exactly. You start looking at the folder structure. You can see that this application is a Java application. You can see, look at the logic. Look at the Java folder. Click on the second folder, the folder right under that Java/main. Yes, this no, the Java/com. No, these ones are images. Yeah, yeah, exactly. Now, can you see? You have the database folder, you have the models folder, you have the securities, the utilities, all the tools and logics that are used to build this. Okay, click on models. Okay, click on customer.java. Yes, keep scrolling. Can you see? Can you see code? So when you get to that level of understanding, where you can understand code, you will understand that this code that is here now is just a syntax that is used to relate to the database. The database is where information is stored, data sets are stored. So this code here is just doing something. What is it doing? It is just telling the database, look at the things I want you to store for me. This is how I want you to store it. Take for example, line 48. What does it say? This is Java or this is not JavaScript. But when you grow, as you grow, you can read any programming language, any syntax, and you understand what it's actually doing. So line 48, what does it say? Public void set account number, string account number as argument. This account number equal to account number. The long story cut short is that we are writing a function. Anywhere you see brackets is a function. So public void set account number is a function, a public function with the errand, the instruction to bring about to create an account number, a string. String account number is the argument. The argument is what are we actually doing this for? We call it argument encoding, not because it is something to start shaking about or it is something that will give you headache. We call it argument because it is the reason why we are doing what we are doing. So what are we here for in this function? We are here to set an account number as a string. Then we have the braces, we have the curly braces, which now further defines this function as saying that a particular account number, that is this dot account number, should be equal to the value of what? An account number. So this thing that we are doing is just we are explaining to the database that we want it to have a store for account number. So we are now calling this function saying, oh, Mr. Database, I want you to have a function where you store account numbers. And how do you store this account number? What do you call it? It should be a string. And how do you express it? What is the name you call that string? Account number. That is what you see in line 50. Say this dot account number equal to account number. So that is all for now. We are not going to go too deep today. I think we have taught some code, we have looked into some code, and it is so wonderful and interesting that we are looking at code from day one. So let's go back and then continue with some of the theoretical things we need to grab and understand as we go in this career path, as we go on in this career path. Great, great, great. It's nice to have us attentive and active here. Awesome, awesome, awesome. Right, you can give us a thumbs up. You can give us a thumbs up. Oh, wonderful, wonderful. I see you, brother. Yes. I feel you, bro. Okay, so we are done with GitHub. Bright has a GitHub account. Victor has a GitHub account. So we are now talking developers to developers, bro to bro. So let's get moving. So you can close your screen. Congratulations, Victor. Congratulations, Bright. Yeah, you can close your screen. You now have a GitHub account. So you can go back to it to set up your profile, find a picture. If there is a picture of you wearing suit and tie, that would be very, very awesome. As you can see in my own, I didn't have a suit and tie then, so I just used a plain trouser and a plain shirt and took some nice picture and posted them. So you can just find a corporate picture, put some don't even care, some employers don't care. You can put an avatar, but the most important thing is just try to fill up your GitHub account with content that will make it easy for people to know who you really are. So that's just the major thing that you'll be doing using by the advantage of your profile so that people can really get to know you. And then links, you can add your LinkedIn where you saw that edit profile. That's where you can add your LinkedIn, then your portfolio websites. You can add a lot of links to where maybe your projects that they can see and stuff. Just make your profile interesting enough that somebody that wants to know you and see if they can trust you with the job role and with their code base, they will be able to read through your GitHub and say, this person really knows what he's doing. I think this person is a developer. I think we can trust him. I think we can just leave this project to him or her. So that's that for them. So we go back to our discourse. I think your screen is still, you didn't shut it down entirely. I don't
My
know.
screen?
Yes, I'm still seeing VC at the center. I don't know why.
Still see my screen?
No, it's not like your screen is showing, but at the center of my Zoom, I just get to see VC. It's more like your screen is not sharing, but you're still the one at the center of the meeting. But that's not actually the problem.
I think his screen is no longer sharing. What you should be seeing is
I'm showing it again.
no, can you
Yeah,
stop can you stop sharing it and Victor?
yeah.
What you're seeing is
Eh,
just his avatar created by default.
yes, exactly. Oh,
Yeah.
yes. Even now, I'm now seeing yours. Okay, I get.
Is
Sorry, I'm
because
not.
is because he was speaking or his microphone was turned on. Then you could also put
Oh,
up a
great.
whiteboard in case you want to proceed with the whiteboard. Yeah.
Yes. Okay. So, okay, we're going to continue. So I'll put up a whiteboard now. Whiteboard, all you. Yes. You white. Okay. So can you see that? Can you see our whiteboard where we are writing basic concepts? Oh, great. Okay, so let's project now have our GitHub active. So maybe we are going to have another break, 5 minutes break by 10:30. I believe by then we have gone deep into the basic concepts, and then we come to use the remaining 30 minutes to, make a roundup of the things we have discussed and finalize the class for today. So we can just proceed. There's no more time. Before you know it now, it's 10:30. We just have 20 minutes left. So I'll use that to, dive deep into these basic concepts. So we've talked about variables. Variables are used to store data and information They are containers for data that can change during program execution. That is one issue we have with JavaScript that some people are complaining about, which led to TypeScript. So JavaScript now, you called var_x to be bright. After this function, you might come somewhere else now, write var_x to be Chinedu. And then you type function, get z, this one. It will now show you Chinedu is a code tutor. But originally, what did we have? We had z as Hamilton, not Chinedu. So when you do var z as Hamilton and you get Chinedu, and you now go another place and do var z as Chinedu, and then you get Chinedu, doesn't really make sense. Integrity-wise, it doesn't. So that's a challenge that JavaScript has. So imagine you are now writing a code, you are building an application, and you now say variable calculation equals to 2,000. And then you come after some place and you write variable calculation equals to 30,000. What do you think will happen? When the code is executing, when the code is now running as an application, it will be confused. You told it that variable calculation is 2,000. You are also saying it is 20,000. So where's the disparity from? It does not know. It will throw error for you. So these are the challenges that JavaScript developers have been having when we get a bit careless, which cannot be avoided. It happens as often as rain falls in the rainy season. I can remember being through a bug for hours. What was the problem? Comma. So is that interesting in programming? It's actually so much fun when you encounter such problem. You just laugh at yourself and laugh at how crazy life can be at times. That's an insignificant thing as comma kept you at one point for a particular stretch of hours, even for a day. Sometimes you just have to apply time management and just go to do something else so that if your employer asks you what you do for the day, you will not say that you are looking for where your comma was missing, because it will not make sense. You just have to find something to do to patch up, and then maybe go out, stretch out, drink some water or some coffee, feel good, and then you come back only to be reading through the code and then see that that is the comma that is the issue. So variables in JavaScript, when we are declaring variables, it actually brings up some concerns. That is why we now have what we call lets. Instead of using var, we now use lets. So we say let's x equal to, let's y equal to, let's z equal to. It will help in generating some consistency for the variable we are calling. Then we now have TypeScript, which will make you define the actual value. If you say let x, you will have an interface, describe x by itself. I'm seeing a notification. I don't know what it's for. Is anybody trying to raise hand? Is anybody trying to warn me about something? I'm hearing like a bell ring.
So it means someone just joined the class.
Oh, awesome. Okay, we have Promise Chiamaka on the call. Oh, interesting. Welcome, Promise. We are recording this session, so feel free to follow up on what we are doing currently, and then you can get to watch the recorded session and catch up. It's going to be an exciting experience. Maybe in the next class, we'll get to hear from you, get to know your name, get to know your hobbies. We have done that in the previous class, and we can do that in the next class. For want of time, we won't proceed with that. So once again, welcome, and just try to follow up, and we know that it won't be a hard deal for you to carry along, and we'll do all we can to make sure you carry along as well. So, okay. TypeScript will help you define X properly. And then you say bright. is a name, and a name describes a person. TypeScript will make you do this, not particularly in this syntax. Sorry, sometimes I can be rusty on syntaxes. It might ask you to have a type of X. And then what will you do there? You would define X. We define X. X is a name of a person. And person is a human being. So you do this in order to declare bright. So TypeScript is a bit more verbose, but what it protects you is the situations that you could have in JavaScript that could lead you to bugs. So what do? You use more time to write better code that will take you less time to debug. But JavaScript, sometimes, if you are not careful, could allow you make some mistakes and keep going on. But TypeScript, once you did not declare Mr. Bright to be X properly, it will tell you come back. Oh, no, go back, go back. Tell us what Mr. X is actually. Is he bright? What is bright? Who is he? Where is he from? That is what TypeScript will insist on you to do. So the JavaScript will just allow you, okay, say, oh, bright, no problem. When you come again, JavaScript, oh yeah, make X to be Victor. I need X to be V. Oh, okay, so you want X to be, no problem now. Oh yeah, Victor X. Then when you now start running the code on compilation time or deployment or production time, you now discover that the application is jamming. And then you begin to read 1,000 lines of code or 3,000 lines of code to discover what the problem is. So it's how interesting coding can be. So we try to implement all these best practices and caution in order to increase our productivity and reduce the time we spend on bugs. So that's all for variables. Let's just look at something else. So they are used as containers for data that can change. Yeah, constants. What are constants? Constants now make things easier for us. When we say const, okay, we have used bright before. Let's use promise. Yes, let's use promise. Const P, exactly. P for promise. Wonderful match. Oh, const P equals to promise. When we do this, what happens? You see that wherever in the application that you are running const P, that you are calling const P, what you get to see is promise. Any other thing that you write, it no go agree. It won't agree. It won't consent to that. Understand? It would not consent to that. Please, can you just give me a second? Okay, so const P equals to promise. This persists and insists on the data you are giving. Is a fixed value. It creates fixed values that don't change throughout the program execution. So what you now ask me, is that right? You now ask me, why do we now have need for var or let when there is const P? Is that question not valid? You can give a thumbs up. If we can just use const throughout the application, why do we not have why do we have need for var and let that can be changed in the value of in the consequence of time? We have this because things change. She one wise is they said people change life as life goes on, people change. It's the same thing in code. You might be executing a particular code, and once Bright executes his task, we want the new person that would assume the position of Bright, because Bright has graduated. He's no more a junior developer. He's now a senior developer. We want a junior developer, and Hamilton is a junior developer. So we want to bring in a junior developer like Hamilton. All we have to do is tell the computer that from henceforth, that X will no more be Bright, that it will be Hamilton. So that is the use case where you see that var or let can be used. So nothing is useless, nothing is a mess, nothing is a mistake in programming. So constants don't change throughout the program execution. So when you are declaring a const, we call it const. When you are declaring a constant, knowing that you are making it a permanently immutable, we call it immutable, permanently immutable sets of data. So a constant is a permanently immutable set of data. So variables can be changed after a function execution, because maybe that variable has served, that particular value of the variable has served its purpose. We now want the variable to assume another particular value or another particular form. We don't want the variable now to be chicken. We have eaten chicken in Christmas. We want to eat turkey in New Year or goat meat. So const variable suya. From chicken suya, we go to turkey suya. Forgive me, I'm using suya as an example. So I'm just trying to make everything applicable real life. So this is what we do when we are calling data that might be vulnerable or that might be needed to be altered and changed. Yes, and then we use const for sets of data that we are sure that we don't have any reason to change moving forward. Keywords. What are keywords? Keywords are reserved in a programming language with special meanings, just like when you have new. Anything you want to call and you are saying const x new and you type it like this, my brother, no go work. My sister, no go work. It's not possible. New is a keyword in JavaScript. So no matter what you do, make sure that there is nothing that you want to name that you call new, because it will not answer you. Or you want to, you say float, it will not answer you. Or you say math, you want to call something, you call it math, variable y equals to math. It will throw error immediately. It will tell you that math is a keyword for which you can get math.min, which means the minimum mathematical value, or math.max, the maximum mathematical value. So how can you now come and use this word that I now use to understand what I am doing, and you now tell me to give it another name? It will make me confused. That is what the computer is doing. So it reserves some particular kind of words as keywords, which help you define what you actually want it to do. So we have new, we have maths, which is used for mathematical calculation of numbers. We have float, which is used for calculating decimal values. We have a host of them. My brain is actually trying to process a lot of things. I would have loved to show us more examples of keywords. So yes, I can check that up briefly. I can check that up. JavaScript keywords. So we can have more lists of keywords. Okay, we have any. They are just any. You can use any, especially in TypeScript. Use any to, describe the type of an object or the type of a variable that we are calling. You understand? We can put it most of the times, you put it as argument when you are asked to give a definite prescription of a variable. You now say, oh, this one I cannot update it again. So when you say type X, so you go here and you now define it to be of what type? N. You now call the function what you want it to. Then we also have floats. Three over 7. It will give you the decimals of what? 3 over 7. Am I right with this syntax? I'm not sure. I really doubt this syntax that I wrote. About that, you don't have to know every syntax, so, but you just have to know what you are doing and the way to go about it. Okay, so that's great, that's great, that's great. So floats, basically, I don't know if the syntax order is correct, but we use floats to find decimal figures, to calculate and display decimal figures. Now, how about new? Take, for example, when you are writing an application and you are calculating a type of value and you want to get new, the latest dates, what do you use? You use the new date function. And the new date function does what? As long as the application is run wherever or whenever, in 2000, in 2025, in 2028, in 2029, 2050, in whatever year in the future, or if like some storylines go, people travel back in time and see the application. Whenever they click new date, they see the date, that particular date in time. So these are keywords. So you cannot come and be writing code and then you want to describe something and then you use keyword to describe it. If it is not what that keyword is meant for, you are on error. So that is keywords. We'll be using this as we go forward into code. And I know underneath you are going to love it. Yes, 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 yes. Okay. What are operators? Values. Operators. Symbols that perform operations on variables and values. Like plus plus, like minus minus. What is it going to do? When you say what? Count plus plus. What are you trying to do? You are using an operator. Count plus plus. It will do what? It will check whatever is count, the meaning of count, and it will increment it. We call it incrementation. It will increment whatever is count. So if count is 1, and it checks that the value of count is 1, and then at the end of that code, you write count plus plus. Whenever the function that you ended with count plus plus is called, it would increase 1 to 2. If you want it to increase 1 by 2, you do this by 2 steps. You do this, count plus equals 2. What will happen? It will increase whatever is count by 2. So if you call a function and the original value of count is 1, once you now come to the end and write that count plus equal 2, what the function will now do is it will take 1 as an argument and then add 2 to it, and then what you get is 3. When the function once again, you get 5. When it's once again, you get 7. When it's once again, you get 9. So these are amazing things that we can do with code. So this is a mathematical operator. Mathematical or arithmetic operator. So what did I say again? Operators are symbols that perform operations on variables and values. So for want of time, I'll just copy and paste this definition for you so that when we come back, we just get through data types, control structures, functions, and methods, and then that will be all for the day. Yes. So what next we have after this data type, well, after these keywords are integer data types, integers, floating points, strings, boolean, arrays, objects. So once we get done with these data types, yes, we have understood the types of forms or ways in which data can appear from the computer, in which data can be fed into the computer. That is enough justice. That is due diligence for the day. And congratulations if you can be able to master all this. So I will copy and paste this detail about the basic elements, the basic rudiments, concepts of programming and programming languages. So that while we go for the break, you can just look at it and jot them down. Sorry about that. I might have to clean the whole screen. Because we took down some of these basic concepts, but if we didn't, in the course of coding, we would experiment them and get to understand them better. So the basic concepts are these: variables, data, parts of the basic concepts, variables, constants, keywords, operators. So we are going to be taking a break now, and we are going to be returning in 5 minutes. Let's just keep it to 5 minutes. So we are going to be coming back by 10:36 to continue and round up the lesson. So you can just, in that time, be looking at this, and then very soon we'll be back and we'll call it a day. Congratulations, everyone. It's not easy to have stayed this long. It takes a lot of focus. It takes a lot of time. Most of us have something doing. So congratulations for making out time. You are already giving it the work. You are already putting in the work. So when you say you are a software developer, you beat your chest and you say it out because you have given him the time, you have put in the sacrifice, and the sky can only be our limit. Forget anything you see content on the net that's AI and we take the job of software developers. It is those that don't know what they are doing. So keep it up, keep the spirit up. You can only but get to above the sky. Energy, energy, energy. We are already eating 1 minute. Sorry. Oh yeah, we are mute. Hello, I'm back. I took one more minute, although we went up by. Oh, great. I can see, Bright, you are there. Thumbs up, thumbs up. Let me see your thumbs up. Let me see your thumbs up. Victor, are you there? Promise, are you there? Can I see your thumbs up? Let's not get tired. We are at the end of the journey for today. Cheers, everyone. Congratulations. It's not easy. It's not easy. Respect. That's what it takes. That's what it takes. Nothing else. Your time and your attention. And it's just a matter of time. We'll get there. Get there. We'll all get there. Me like this, I'm still learning. Oh, I have a lot to learn. But thank God for the growth. Thank God for the progress. At least now we can find our daily bread with it. So it's my prayer that each and every one of us here, we soon begin to find our daily bread with this thing. And from that point, well, things can only get better. Yeah. It's just all about the sacrifice. Then things will work out. Consequence of time. We are back. Okay. So we continue. Data types within the next 20 minutes, and we call it a day. What are data types? Data types are just the ways, the structures with which data is being conveyed to the computer, or through which data is being presented or rendered to the user. So data types are just structures to communicate data to and fro the user, to and fro the user, to and fro the user, to and fro the computer. So what data types do we have? We have integers, we have floating points, we have strings, we have booleans, we have arrays, we have objects. Let's clear the whiteboard. Okay. Data types. Data types. Strings. When you hear strings, what comes to your mind? Oh, by the way, I'm an instrumentalist. Oh, I've been playing instruments from teenage, so I enjoy it and use it as hobby. So when we talk about strings, string instruments come to my mind. Guitar, bass. There's a particular module in the keyboard, Casio keyboard, that is called strings for playing worship and hymns. Yeah. So, but that's not what we are trying to talk about. Sorry for the digression. Just trying to make everything look more human and less technical. Strings, what are strings? Strings are just a way to envelope data, especially text kind of data. This is what strings mean. Anywhere you see string in computer programming, my brother, my sister, na string be this. So that thing wey they call quotes, apostrophe. It is string that we call it. Any data is not just these two things, but it's any data that is stored inside of these quotes is a string. So when we have Victor like this, Victor is a string. Why? Because it is housed, he is housed inside of these quotes. So wherever you see Victor in your code base, know that Victor is a string. Call Victor a string. Because of what? Because he was housed inside of this. You can also house him inside this. It's still the same. The computer will read this and this as the same thing. What is this one is double quote, this one is single quotes. So that's just difference, which the computer does not take to heart. You can still do this guy, backtick, Victor. This brother still is a string. You can still do this uncle. $, template string literal. Don't worry, we'll get to all these things in consequence of time. Victor. Victor is still a string, as you can see it here. So strings are data stored with this kind of signs. Double quotes, single quotes, backtick, template literal with back housed inside of backtick. So why would we put things like this? What is the need of doing this kind of thing? Why is it necessary? It is necessary because we want the value of this data to persist, especially when it is a text. So we store it in a string and then we carry it around in the whole application. If we store Victor as Victor, it will be very, very difficult for the computer to always begin to describe and get to understand that Victor is a string, unless we house him inside this. So when the computer now sees Victor, you'll be like, what is Victor? What is Victor? You now see that Victor was housed inside the quote. You say, oh, so Victor is a string. No problem. String. Come, look, they do the errand we do. So that is strings for you. Strings are sets of data that are put inside the quotes and can be called and extrapolated from any point in the code. What are integers? Most of us science students will know what are integers, and it's the same thing even in programming. 1, 2, 3, 4, 5, 6, 7. These are integers. From 1 to 999. Yeah. Then from 4 figures, I think. No, it could be less. Sorry, I'm not putting the figures, the actual data so correctly. But we have big ints. I think 100,000 is still integers. 100,000 is still integers, yeah. But when you have this kind of data like 10 billion, 30 billion for the account, all those ones are big ints because the computer, it takes the computer compiler a whole lot of time to convert these numbers to machine code, to zeros and ones. Imagine giving the computer a task to convert this guy into zeros and ones. What do we call zeros and ones? Binary digits. It will take a whole lot of time. So what we now do to help the computer to first of all identify it as a big int, and then in the course of time, where necessary and when necessary, it will now try to decide or to break it down, is when we now tag it as big int. We do it something like this. Say big int 10 raised to power. How do we call raised to power again? So you encounter this thing many a times. You just forget syntax. It's natural, but that doesn't change anything. So we write big int 10 raised to power 56. This brother, as a data type, we help the computer in understanding that this is a large numerical value, and so it will also help it in storing it appropriately and then calling it where and when need be. So this is for big ints. Big ints are integers that have a huge data value when being converted from normal integers to binary digits. I will get back to us maybe later on the limits that makes a number that numbers range from to become big ints instead of integers. Okay, so that's for that. Booleans. Booleans. Booleans are what? Booleans are two-sided sets of data which just have to be either one or the other. So when we say bool, we are going to write either what? True or false. So when we have a function, we have a value. When we have a data or a statement or a declaration or a result, a consolidated result of data, and then we are trying to describe it. We are trying to ask the computer to verify it, whether it is true and false. We use the Boolean value. This helps as a keyword to explain to the computer that what we are asking, what we want to know, is whether this actual value, the value that was produced or that is being called in a function, is true or false. So that is what Booleans are. Booleans are conditional values that explain the state of a data or the correctness or accuracy of a data. So when we say example, this is not sign coding, strictly equal to 4.0. I will write something like, this syntax is not actually correct, but for the sake of time, we are just making it brief. Results. If you run it in a code, it will run through error because I'm first expected to write let results. Let's just do it. Let the result be equal to number. So 4 is not equal to 4.0. Then we run console log results. Ooh. Yeah. So what will it give you? It will give you false. When you console log this, it will give you false. It will give you true. I'm sorry. Because this is not strictly equal to this. Yes, it's not strictly equal to this. So it will give you what? False. But if you say, is it equal to this? It will give you what? True. Why? Because the value of 4.0 and 4 are the same. But looking at it, 4.0 and 4 are not the same in appearance. So when you run this, it will give you false. So this is what Boolean values are meant to do. Boolean values are meant to store data that actually exists in 2 times, that can only be classified or characterized in 2 times by the level of their accuracy or clarity or integrity. So is either a Boolean value is true or it is false. So that is all for Boolean. Strings. Oh, we have done strings. Arrays. What are arrays? Arrays are a house, a basket. Arrays are a collection of data in several types. You can have an array of strings. This is the array housing. This is the array symbol. You can have an array of strings. Victor, right? Promise. So this is it. You have an array of names of people in this class. It is housed with this symbol. So whenever you see this symbol, you know we are talking about array. So this is an array of names of people in this class. So what are arrays meant to do? Arrays are collections of related data and functions. If they are not related, please don't put them in an array. If we are not in this same class, please don't put us in an array. Victor is here, Bright is here, Promise is here. Okay, then let's put them inside an array because they have something in common. What is that thing they have in common? They are all in this class. So that is arrays for you. That is arrays. So what next? We have objects. objects. What is the sign for objects? This. So what are objects as well? Objects are collection of related data as well. But what is the difference between arrays and objects? Someone might like to ask. Objects might not be organized, but arrays are organized. So you can have an object looking like this. Name, math, limit, max, size, 11. This is an object. It defines a particular thing. It breaks down the features of a particular thing. So what are we calling here? The objects. What are we calling? The object of maybe an account of the total number of sales made by a company in the year. So the name of that account is math. The limit is the maximum range of the figures that can be gotten. The size, 11 digits. The company is closing 11-figure deals. So that is, we are describing the what? The income. Sales income. So sales income is an object which has the value. This. Okay, let me break it down. Hamilton is an object. So when you want to define Hamilton, name, age, 13 years. I see there's one. Height, 2 feet. God forbid. So you can see this is an object. So this has gone below. Okay, great. So this is an object. Name, age, 13, height, 2 feet. This is an object. What does it do? It defines a particular set of data. It breaks it down to its integral values. So when we talk about objects, objects are elements of a particular data. Objects can be elements of an array. That is where arrays come to be a collection of what? Data. So we can have all these guys in Victor. Victor has a name, Vic, age, 2 years, height, 10 feet, bright, name, age. We are a collection of young men. We are a collection of learners that have come to understand coding. So what is happening here? We are making an object to define our integral values. That is what object is a collection of related data. So every element of an array that has an object, they are always similar. But what makes the array the more that nests all of them up is that it's more like the basket. It's more like the warehouse where all these objects are put. So you can put integers, you can put objects, you can put arrays into arrays. Just like you can pack a basket into another basket, you can have an array of an array. Oh, this guy is getting too long. Yeah, sorry about that. So we can have an array of an array. We can have an array of an object. We can have an array of strings. String values. So this is all about arrays. They are a collection of data. Any type of data can enter, even Boolean. You can put any type of all these data can be housed inside of an array. So once again, what are basic concepts? What are the basic concepts that we have learned today? We have learned about operators. We have learned about keywords. We have learned about what else? Integers. No, we have learned about constants, variables, operators, keywords. We say variables and contain data that can change during program execution. Constants cannot be changed. Keywords are names that the computer recognizes. It does not want you to call anything new and then call it to be what it already registers as a keyword. Don't attempt using keywords to program a computer unless you are trying to use the value of that keyboard to define what you want it to do. Operators, what are operators? They are symbols that perform operations on variables and values, just like the plus plus, minus minus, plus equals. So what are integers? Integers are what? Data types that portray numbers. What are strings? Data types that are housed in quotes, single quotes, template strings, and the rest. What are booleans? Conditionals of true and false. What are arrays? Arrays are collections of data. Objects are definition of the integral features of a data. Take for example a human being. Take for example a string, a boolean. Not a string or a boolean. A string or boolean value. The integral parts of a string or boolean value can be housed and described in an object, just like we called Hamilton and we then broke down his features, name, age, and height. So that is all for today. Congratulations for this introductory part that you are able to see a hand clap, hand clap, hand clap, hand clap. Congratulations everybody for going this far. I'm not seeing the hand clap. Okay. Great. Seems like we've loaded your mind with a lot of information. Just take your time, sleep over it, watch the video again, and then there are some materials that will be added to Discord. Watch those videos, and it will help you understand these concepts better. When we come tomorrow, we step on it, we step up the game, and we hit the ground running. So it's going to be a
All right.
wonderful.
Yeah, thank you so much, Hamilton. So after this class, you can check up on the learning resources channel. There'll be some videos that will be dropping there alongside the recording of this class. I'll be just dropping there so you could go through them and ponder over everything you've learned in this class. If you have questions, don't hesitate to drop them in the tech support chat. We'll respond to them as we progress. I think that's all for today. We'll catch you guys in the next class. Hamilton, do you have any other thing to say?
Nothing else. Keep the spirit alive. Keep the hope alive. The sky is the starting point.
All right. Does anyone have any questions?
Not at all from my end.
None from my end too.
All right. Victor, do you have any question?
No, I'm good.
All right. So also understand this is just an introduction to computer science in general, right? So as we progress, we'll start introducing you to the programming languages gradually. So don't feel like you're lost or you've lost a lot of information. It's a very gradual process to follow. Hamilton, you could just close up and then call it a day.
All right. It was a great time having everyone here and learning from each other and doing what we had to do. I hope to see you all next tomorrow. Cheers, everyone. Cheers. 8 p.m. remains the time.
Thank you very much.
Yeah, it's night over here. Good night, Promise. Good night, Bright. Good night, Victor. Good night, my Oga, Chinedu Victor. We'll talk later.
All right, cheers, everyone. The call ending now. Yeah.
Cheers and good night, everybody.
Yeah.